Good morning, everybody. I'm actually presenting on behalf of my student, and this is actually a fourth-year bachelor student's work. But this is also in collaboration with me. I've just started as assistant professor at Ritsumeikan University. Everything that I did, like the past few months, has been like very new, and I will talk to you today about comparing two environments, augmented reality and virtual reality, and we would like to situate it in a second language vocabulary learning scenario. Okay, so maybe we already are familiar with these memorization techniques, and most of the time we always try to think about it in a spatial kind of way. Okay, so I'm just showing you, it's not copyright infringement, but we always have that kind of visualization of mind mapping. So in the cases of like crime scene, triangulating where the person is or something, or we can also use these things for memorization stuff. The thing is, what if we can utilize virtual and augmented reality spaces as memory palaces themselves? Okay, and there have already been a lot of studies regarding memorizing things in AR and VR spaces, and there are many different kinds of devices that are used here. So, for example, there is some projection systems, and I was able to do a master's work on comparing AR and VR for like a blown up pilot cockpit keypad or something, and then what happens if it's memorized in a room layout scenario. And then there are also already some prototypes of memory palaces for AR mobile devices as early as 2012. So these are some of the things. And what I'd like to focus on is this topic called memory palace. And some of you might know this as the memory of loci technique, where we use a familiar environment to anchor certain memory stimuli. So for example, if I want to think about or memorize my shopping list, maybe I can, designate some words or ideas or even some objects and put them in specific places. Like library, you have books, or cafeteria, you have food. Okay, and then that shopping list will continue. And what will happen is, after a while, after you've left that place or left that scenario, maybe it's stored in your mind in terms of semantics, where I associate this shopping list with particular places or specific things. Okay. Now, in the case of our study, we wanted to try to explore this kind of, or exploit this kind of memory palace scenario in terms of learning a new language. Okay, so especially foreign language. Okay, because the thing about having these kinds of foreign language scenarios is that you don't know much about the context of what that word is. So maybe we can try to imagine some things. So let's say, for example, you have a specific kind of object that sounds like it in the foreign language, but you know it from an English language. So there's that kind of additional layer of association. So there have been some studies already where there's a VR version of it where you can facilitate more imagination if you have more interactive and more imaginative, immersive environments. Or for example, there's also AR-based learning ones where the whole thing, the memory palace, is very reliant on the actual tangible real objects. So those become the anchors of this memory palace. So now, we try to highlight the advantage of XR technologies because they promote exploration, interaction, and personalization. You will see it later with the tasks that I will show you in both VR and AR. So the difference of AR and VR we highlighted in this study are the following. So we focused only on the visual aspects as differences between AR and VR and how they can influence memorization processes when used in a foreign language learning task. So for example, here, we wanted to highlight things like environmental clutter, right? So when we try to explore AR and VR scenes, there's most likely there are many kinds of differences. So, for example, in AR spaces, we cannot really control lighting and external effects in this way. But in VR space, since we can actually engineer the immersive environment, it's much more controllable that way. And then the second one is that there is also ease of skill transfer when we are talking about AR spaces, because, for example, if I learn something in AR, maybe I can easily apply it to the real world, because most of the tasks that we perform are in the real world as well. So that's why learning in simulators can be used in this scenario. So that's the second difference. And the third one is presence. So this is where we try to differentiate the usual VR headset experience with, for example, the Microsoft HoloLens experience, where the interaction modes are different. So we wanted to highlight these as well. So you can see actual hands in AR. And then for VR, as much as we have been developing a lot of hands there, or floating controllers there, there's this difference as well. And the second thing is, since we are in augmented reality, maybe you can see your real body in the real world. So that's why it's a very big affordance. And then for VR, usually we don't have a body, or we just have a proxy body, so there should be some presence differences there. So for the research background, so we wanted to know the effects of the different visual properties in AR and VR on learners' learning experience and performance, and they have not been explored before in this way. But we wanted the goal to prove if any of the mentioned differences between AR and VR actually have statistically significant difference, maybe in terms of a memory test, or other kinds of metrics as well. So things like how long did it take them to memorize some things. So in terms of the three properties that I showed you earlier, this is what we have so far. So AR is a better learning environment because it immediately has a high level of presence in that way, because you already see the real world. And then for memory transfer, it's easier because you are already in the real world. So the caveat here is you would want to do the memorization test in the real world. Okay? So the second one is, however, if we can present an immersive environment where all of the other external factors have been removed from environmental clutter, then maybe the fidelity of the environment can actually have a role. Or maybe we can do some much easier memory palaces in VR as well. Okay, so this is not just my advising kind of research project. So he also came up, so the first author of this paper came up with these kinds of little experiments or little initial studies. So the key features that he wanted to do with this study is to have a more personalized and exploratory memorization. So he tried to think about, hey, what if I actually have more than just one object for representing a certain word. So we try to make as many objects as available with, let's say, for example, in this experiment, we had 15 items, and then there's actually a set of 30 objects or something. And then we have these kinds of word lists where we try to think about, what if we make sure that the words that we would want to memorize are spatially or visually relevant. Okay, so these kinds of considerations we try to do because it's a little bit hard to control these kinds of user study. So the experimentation method, we are still actually in progress right now as we speak. So he has been doing this preparation in our university right now because at this moment we are finishing our thesis time at this month. So the end of the thesis submission is end of the month. Here we have a survey first, and then we will ask users or participants to train in a demo scene. And then the experiment is we wanted to test it in the AR condition, VR condition, and possibly a control condition where there's actually no head-mounted display. And then the post-experiment, we have a memory test and usability evaluation for this. Okay, so this is the layout that we currently have right now. So again, since there are many external factors that happen when you present something in the real world for AR, we try to minimize as much things as we can, but still there are some easily understandable objects in the scene. So for example, we put in a simple room layout with tables, chairs, boxes, and ladder. So we have that. And then, so this is what I'm talking about. So when we have, like, let's say, for example, 15 word tags, we want the users to attach these 15 word cards or 15 word tags to specific virtual objects and then place them in specific locations in the real world or in the virtual world for VR. Okay? And then, so this is one demonstration of it. So I will just show you. This is done actually using the HoloLens, so you can use this here. So I have to note, though, that this is actually the LiDAR scan of the room in VR. So what you can see here is a scan from an iPad, okay? And that's actually the duplicate or the twin of the room that I just showed you earlier. So this is the AR version. Okay. So here, okay, so I already have this. Okay, so this is the demonstration of the task itself. Okay. I think it copied. So again, I'm just showing you that there is this attachment with the word and the object itself. And then also, we tried to prepare like 2 cameras on top of the ceiling so that we can actually try to track the movement of the person. So maybe suddenly the person will move there. I hope. I think yes. So there's a person, right? So aside from actually getting these kinds of test results, we can also try to look at it from like HMD positions, rotations, and see whether or not like people are staying in one place or are they walking around. So that's an additional data collection point that we would want to do. So we can do a video analysis of that. Okay. So aside from the positions and the vocabularies themselves, we can also ask them at the end of the experiment, what are the things that they're thinking of when they're trying to memorize something. So what kind of cue are they using to memorize this? And then also we have some like statistical analysis at the end of this. So the current hurdles that we have right now, because the result has not yet been done, is that we tried to conduct preliminary tests. So for the past few months, and actually they had a very hard time trying to get acquainted with like AR and VR as well. So we're talking here about, a pool of students who don't know anything about AR or VR. So we really have to train them how to use the system. And then we still have too many objects on the scene at that point in time, like maybe 4 months ago. So we had to like drastically reduce the number of objects on the scene. Okay, so I think another thing is that in the new iPads that we have, we already have these kinds of mesh scans with LiDAR. And we were trying to compare which one is much better in terms of representing a VR space. So just because here in this comparison here, like the table for the words and the objects, they are very much in stark contrast with the environment here on the left. But on the right, sometimes we have a very difficult problem trying to find where are these objects on the scene. So to conclude, we still have to carefully find out how to best create this kind of situation or this environment. So if you have any questions or suggestions on how we can move forward with this, I'll be happy to take them. So thank you very much for your time.